All right, good morning, kids at home. So today we're going to be looking at percents with bar models. Bar models are the same thing. Let me see if I can get to focus for you. Focusing. There we go. Bar models are the same things as strip diagrams. They are going to be strips that can help you see what percent is happening. So the things that we need to go through over first is we need to talk about what is a tip. So a tip is money added to your bill as a thanks for service. Okay? So if a waitress does a really good job at a restaurant and you want to tell them thank you, you tip them. Your bill might be $25, but you want to tip them $5, so that means you're going to pay the $30. The $25 will go to the restaurant for the food and drinks that you had, and the $5 will go to the waitress as a thank you. Okay? And we also need to look at discount. If I tell you you get a $5 discount on a pair of shoes, that means that you are getting $5 off. Okay? So it's money that is taken off of the total price, and a sale price. Let's talk about that. I'm going to do these together because they're very similar. A sale price means that money has been reduced off of the total price. Okay? All right, so when we have a tip, it's being added to the total. When we have a discount or a sale price, it's being taken off of the total. So this one is adding, this one is subtracting. So let's think about what the bar models would look like for these. Okay. So this is the cost of your food and drink. Let's say it's $18. And you want to add, so this would be 100% of your bill, right here, 100% of your bill. When you add your tip, you're adding on extra. So here's your tip. And let's say we gave a tip of $5. Okay, so you added more than what was expected, so you're paying more than 100% because part of it is going to the waitress. Okay, so when you have a sale or a discount, okay, so here's 100%. When you have a sale or a discount, you're getting to take money off. So that means you're paying less than 100%, okay? So you will actually end up taking that off, and this right here will be what you pay. What is paid. Okay, maybe let's say our whole bill was $80, and we took off 10. So what would we pay? 70, okay? So sales and discount are very similar, and that's the way they will look. So let's think about this. If we know what 100% is, could we find 10% in our head? Let me adjust this camera so that y'all are getting a good view. There you go. So if 100% equaled $100. Could we find 10%? Well, how many 10% are inside this 100%? Well, let's look at it. So here's 0%, and here's 100%. How many 10% are inside there? Well, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that would be 10 of them. Okay, they're not perfect, but there they are. So how could we find 10%? Well, 10% would be right here. Well, let's look at our number. We're going from 100 to 10. Well, what do we do mathematically to go from 100 to 10? Well, we divide by 10. So in math terms, we tend to say we're taking off a 0. Well, we're doing a place value shift by one place value. So that means taking off a 0. So if I had something that was $100 and I wanted to take 10% off of it, I wanted to do a place value shift. Well, right here is my decimal. So I'm going to do a place value shift of 1. Which means it's now $10. Okay? What if I had 80? Well, right here's my decimal, and I want to do a place value shift of 1 because I'm just moving over for 10%. So now it would be 8. Okay? What if I had $54? Right here's my decimal. I'm going to do a place value shift of 1. So it'd be $5.40. Okay? So that's how we do a place value shift for 10%. Now, what if we had, let's think about it again, $100. Could we find 1%? What are we doing mathematically? Well, that's 100 divided by what to get to 1? Be divided by 100. So there's 2 zeros here, and we're not going to say take 2 zeros off. We're going to say do 2 place value shifts. So let's look at the way it's going to look on a bar model. Here we have 0%. And here we have 100%. Okay. So this takes us down to 10. Now we're wanting to go down to 1%, which is right there. And we're going to do 2 place value shifts. So for $100, if this is our decimal, we're going to shift it once, shift it twice. So 1% of $100 is $1. So let's look for 80. Here's our decimal. Shift it once, shift it twice. So 80 cents is 1% of $80. And if you think about it, 80 times 100, 80 cents times 100 would be $80. $1 times 100 would be $100. And let's look at the 54. There's our decimal. Shift it once, shift it twice, and we're left with 54 cents. Okay? I'm going to switch to the other side of my notebook. Clear up for you. There you go. All right, so let's look at a sample problem. A ticket to the movies costs $8. You have a coupon. So is coupon going to be adding money or taking off money? It's going to be a discount. It's going to save us money. So we're going to take money off for 5% off of the movie. Price of the movie. Okay, so let's do some math here. I'm going to draw me a bar model. So this is 0%, and this is 100%. So if I had to pay 100% of the cost for the ticket, what would the cost be? Be $8. So right here is $8. Okay? And if I paid 0% for the cost of the ticket, it would be $0. Okay? So let's just do a little bit of math. What would 50% be? Well, that's half. What's half of 8? So that would be $4. Now let's look at our place value shifts. Place value shifts are very easy. I can easily go from 100% to 10% just by moving one place value or getting rid of a 0, as y'all like to call it. So if here's 10%, and I don't know that that's exactly where it is, I'm just kind of estimating. I'm going to take my 8, that's written like this, and I want to shift it how many places? One place. So you see where I did that? One place. So that means 10% would be 80 cents. Okay? 80 cents, because if I have 80 cents 10 times, then I would get $8. Okay, so if 80 cents is 10%, let's place value shift again and figure out what 1% would be. Okay. So look, let's pick it up. We could even come over here, go one more, and remember we'll put a 0 in the placeholder. So that would be 0.08. So 8 cents would be 1%. Okay? If you know 10% and you know 1%, you can find out pretty much anything. And how would you do that? Well, 100% of our ticket is $8. It tells us right here. 10% of our ticket, we just said, is 80 cents. What if I wanted to know 5% of our ticket? What could we do? Well, there's several things. We could take half of our 10%. If we took half of the 10%, that would be 40 cents. Right here, I have 50%. What if I did a place value shift? So go from 50 to 5, I'm just taking off a 0. And this is $4. So if my decimal's right here and I want to move it once, there it is again. 0.40. Okay. Also, if I know 1%, I can multiply it times 5 because I want 5 of them. So we could do 0.08 times 5. 1, 2, 1, 2. And there it is again. So there's multiple ways that we could have gotten that one right there. So how much are we actually going to save if we're getting 5% off of our ticket? We're going to save 40 cents. So how much is our ticket going to cost? $7.60 per ticket after the discount. Let's look at one more. There we go. The cost of a meal is $24. Okay. you would like to leave a 15% tip. $15% tip is about normal for what you would leave at a restaurant. My husband gets really mad because of working with bar models the way that I do here at work. I'm able to calculate these pretty quickly in my head. And so hopefully that's where you'll be able to get with these as well. So let me go ahead and draw our bar model. So here's our 100% and our 0%. What is the total cost of our bill? Our $24. Okay. So we want to figure out what is 10%. Well, remember we're going to do a place value shift. So I'm going to switch colors so you can see it. So I'm going to do a place value shift of 1 because we're going from 100 to 10, which is just taking off 1 0. So you can see where our new decimal will be. So it would be 2.40. So 10% is $2.40. Now we want to know what 15% is. So how are we going to figure out what this 5% is? Well, there's two different ways. So here's 5% and here's 1%. So how do we want to do it? Well, the two different ways are that we can do another place value shift to get down to 1%. So I can move it. No, it's hard to see. There you go. And that would be 0.24, so that'd be 24 cents. Or if I wanted to go with 5%, I could take half of the 10%. Well, half of $2.40 is $1.20. So either way would have gotten us there. So because if I took the 24 cents we figured for the 1%, I multiplied it by 5, it would get us $1.20, and we also calculated half of the 10% it being $1.20. So how much tip are we going to leave? Well, we want 15%, so I'm going to take the 10%, which is $2.40, plus the $1.20 for the 5%. So the tip total, so total tip is $3.60. Okay? So what is the total out of pocket? Out of pocket means how much are you paying with your bill plus tip. Okay? So we're going to take $24 plus $3.60. So $27.60. Okay? So guys, that is your notes. This is a skill that is going to get easier every time you do it. Okay? So in class, we are going to be working on this paper right here. I'm providing it for you electronically so that you can manipulate it as well. Let me see if I can get it to clear up for you. There we go. So we're going to use the 10 tiles pictured below to represent 40 problems on a test. Okay, so here's my bar model, and I'm going to come over here, and we know that this is 100%. Let me switch colors so you can see it a little better. So right here is 100%. And what is 100%? Right here. It's 40 problems on a test. So to get a 100 on that test, you would have to get all 40 problems correct. Okay? So what percent does each tile represent? Well, let's figure out how many sets there are. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So we would take 100 and divide it by 10. 100 divided by 10 is 10. So each one of these tiles represents 10%. And then it tells us to write the amount in each tile above. Oh, hang on. There we go. I jumped to the wrong spot. I'm so sorry. So each one of these is 10%. Okay. How many problems does each tile represent? So it doesn't represent 10%. Each tile represents 10% of the total. So if I'm going from 100% to 10%, we want to do a place value shift. So right now the decimal's right here, and we're going to shift it once. And it shifts between the 4 and the 0. So that would be 4.0. Or you can just leave it at 4. 4.0 and 4 are the same thing. So we're going to write the amount in the tiles above. So this is 4 questions, 4 questions, 4 questions. Okay. So let's fill this in. If we got a 0% on our test, which is over here, 0%, how many problems did we get correct? 0. If we got a 10%, how many did we get correct? 4. 20%, well, that means I have to take the first 10 and the second 10. So 4 and 4 is 8. 30% would be 12, so 4, 8, 12. This one would be 16, and you would be able to complete the chart. Okay. All right, so if Marcus answered 80% of the problems correctly, how many problems did he answer correctly? So 80%, which means he got 32 problems correct. How many problems did he answer incorrectly? Well, that's what's left over. So that would be the 40 minus 32, which means he got 8 problems incorrect. 20% of them were incorrect. All right. Now we're going to look at it one more time. So we're going to use the 10 tiles picture below to represent $32.80 for the cost of a meal. So this is $32.80 for the cost of a meal. Okay, clear that up for y'all. What percent of the cost does each tile represent? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one of these is 10% because 100 divided by 10 is 10. Write the percent in each tile below. So this one would be 10%, here's 20%, 30%, 40%. And then this one is the 100%, okay? So each tile, so this line is 0, this line is 100%. I don't know why that says 900, it should say 90. My numbers are off. Let me check this again. Here, let me get another paper and start over. Sorry, guys. So we said that each one of them was 10%. Sorry guys, it's Monday morning. Here's 100%. So this line right here would be 90, 80, 70, 60, 50, 40, 30, 20, 10, and 100. There we go, that's better. What dollar amount does each tile represent? So each tile represents 10%. out of 100. So that means we were dividing by 10 or taking off a 0 or one place value shift. So I'm going to take the decimal and I'm going to move it one place value. Okay. So it now says 3.28. So each tile represents $3.28. Okay. What is 5% of the cost of the meal? Okay, so how do we want to calculate that? Remember that if we take 10% and we go down to 1%, we would just move a place value, and that would get us to 1, and then we can multiply 1 and 5. Or to find 5%, you could take half of the 10. So I'm going to show you both ways. So here's 10%. I'm going to move the place value to get it down to 1%. 1% equals 0.328, which would be rounded to 0.33. So 33 cents. Or we could take half of the 10%. So I could take $3.28. Well, half of $3 is $1.50. And half of 28 cents is going to be 14 cents. So $1.64 would be half of it. Okay. So what is 5% of the cost of the meal? Be $1.64. Okay. If we would have done this 0.328 times 5, we would have gotten around $1.64 because we did round it to 0.33. I'll show you what happens. Because remember, when we're rounding, we're not working with the exact number. See, we would have come out with $1.65. It's close-ish, but it is an estimate. It's a rounded, so it does go up a little bit. So if Jennifer's meal costs $32.80 and she would like to leave a 15% tip, how much tip would she leave? So we're going to take our 10% of 3.28 and our 5% that we just figured out at 1.64. And it tells us that we would leave $4.92. What will be the cost of her meal and tip combined? So her total cost, $32.80 plus $4.92. Oh, not 6, it's 7, sorry. So we'd have $37.72. Okay. I will leave the last one for you to do on your own. I'm going to pause my screen so you can. So this is quickly how I've set it up. You can see that I went from 62.5 with a place value shift to get 6.25 for 10%. And then I went ahead and calculated 1% at 0.625. So that would be like almost 63 cents. And I calculated half of the 10% at $3.12, a little bit more, so almost 13 cents. All right, go ahead and solve the rest of the problem. So each tile does represent $6.25. To find the 30% off, that means we want to take the 6.25 3 times, because that would be 10%, 20%, 30%, so you want it 3 times. So that would give us $18.75. So what is the sale price? Well, we'll take $62.50 minus $18.75. $43.75. Okay. You do not have to submit this part to me online. That's just for your notes purposes. But I do want to show you what you're going to get electronically for some follow-up. Okay. You're going to get a, well, it's not going to be a paper. In-house kiddos are going to get a paper. You're going to get an electronic version of this. And so what it's going to have you do is you're going to read the problem and you're going to build the strip diagram. Okay? And you're going to build the strip diagram all the way through. Then after that, you're going to get some task cards. There are 7 task cards total, and that's what you're going to be completing for today. If this is still confusing, it is okay. Do not panic. Everybody take a deep breath, shake it out. We are going to be spending the next 3 days on this, okay? Next 3 days, so no worries. All right, do your best. If you get stuck, I will see you at 3 o'clock for tutorials. All right, guys, bye.